I'm Dr. Donna Hauser, a research assistant professor at the International Arctic Research Center at the University of Alaska Fairbanks. And here's my short take on the current responses, risks, and resilience of Arctic marine mammals in a changing climate. So I'm an ecologist, and that means that lately I spend a lot of my time thinking about how recent and unprecedented global warming is fundamentally altering habitat for wildlife. And that's often in multiple, complex, and interacting ways. In particular, there's no place on Earth experiencing as profound environmental changes as the Arctic. Dramatic declines in seasonal sea ice extent, thickness, and duration are key indicators of Arctic change that are expected to have complex social and ecological implications for Arctic marine ecosystems. Regions like Alaska's Chukchi and Beaufort Seas have experienced particularly pronounced sea ice loss. So much of my research focuses on the 7 Arctic marine mammal species that are critical to the ecosystem because they play key ecological roles by integrating ocean variability across trophic scales. They're uniquely adapted to their ice-covered habitat, and they're critical resources for indigenous communities across the Arctic. So Arctic whale species, like the beluga whale, are ice-affiliated, and many populations migrate into the Arctic to feed during the productive summer season. So my research has considered how changes in sea ice cover and the timing of ice could impact populations of beluga whales that have been tagged since the 1990s. So for example, one beluga population started their fall migration over 3 weeks later in the 2000s than in the 1990s. And that later migration timing was correlated with delayed sea ice freeze-up, which means that departure from the Beaufort Sea foraging areas occurred significantly later in recent years, suggesting that some belugas may have expanded access to prey. Our additional work suggests that sea ice is just one predictor of beluga summer foraging habitat, and it's actually oceanographic features that affect prey distribution that are more important. We found no significant shifts in the distribution or amount of optimal habitat during 1990 through 2014, and that further suggests limited impacts of summer sea ice loss. Overall, these results suggest belugas can flexibly respond to changing sea ice conditions. However, we also found significantly prolonged and deeper diving in the 2000s compared to the 1990s, and those are energetically costly dives that could have indirect effects on population health. Other Arctic marine mammals, like the ring seal, directly rely on sea ice for things like reproduction, resting, molting, and foraging, so they're expected to be more sensitive to sea ice loss. Ring seals excavate ice and snow to create layers where their pups are born and nursed and provide protection for predators and weather. I'm part of a team that's surveying snow and sea ice properties affecting ring seal pupping layers. And here's an example of a layer that just looks like a breathing hole from the surface, but when we stuck a camera into the hole, we surprisingly found a flooded layer. And that was due to a combination of last year's thin sea ice and heavy snow, which is a bad combination for a pup who wouldn't have a dry place. So let's shift now to discussing how Arctic change also introduces the potential for new human activities that could have compounding effects on Arctic marine mammals, like the advent of commercial vessel traffic in the 2 Arctic sea routes, the Northwest Passage and the Northern Sea Route. So we're no longer talking about the Arctic that Amundsen experienced over a century ago, when he was the first European to transit the fabled Northwest Passage over a 3-year period aboard a 60-foot wooden sailing ship. Fast forward to now, when we have cruise ships that are over 800 feet, carrying 1,700 passengers and can complete the route within a few weeks. We know from research at lower latitudes that vessels and marine mammals don't necessarily mix well. Vessels can have acoustic impacts on marine mammals who rely on sound in a number of ways, but there can also be the risk of mortality from direct collisions with vessels. I've recently examined the vulnerability of 80 populations of the 7 species to vessels in these Arctic sea routes, and that considered 2 factors. First, exposure, which is the degree of spatial overlap of the sea routes with each population's range, and second, sensitivity, which is a set of variables that considered consequences of being exposed. Vulnerability varied among the 53% of the populations exposed to Arctic sea routes. Whale and walrus populations were generally more vulnerable than ice seals and polar bears. Overall, narwhals had the greatest vulnerability scores, and that corresponded to high exposure in the Northwest Passage. Vulnerability also varied by region. Alaska's Bering Strait is a natural geographic pinch point and characterized by populations with 2 times greater vulnerability than more remote regions. So there's high potential for conflict because it's an obligatory pathway for vessels, but also for hundreds to thousands of migratory marine mammals. So clearly, the responses, risks, and ultimately future resilience of Arctic marine mammals varies among regions, populations, and species. Some species seem to be the iconic losers when we talk about Arctic change, but I think we should restructure that argument and consider this emerging story of variability. So for example, while some polar bear populations definitely show signs of stress, others appear to be doing pretty well. They can be in pretty good body condition. We need to stretch beyond assumptions and instead examine a spectrum of Arctic change responses by marine mammals and more broadly consider resiliency through variations in things like population ecology and health. Part of the problem is there's still so much basic ecology we don't know. Each of these boxes represents a population, shown in green some populations that are increasing, in yellow those that are stable, and red are declining populations. But the vast majority are data deficient and have unknown population status. I think new and diverse monitoring is necessary. One path forward involves bridging our conventional science with local indigenous communities who rely on marine mammals and are among the first responders to Arctic change. Creating partnerships that weave our knowledge systems might lead to new insights and opportunities. Through UAF programs like the Alaska Arctic Observatory and Knowledge Hub, I'd like to expand our community-based observing partnership and also encompass measures of marine mammal distribution, health, and behavior, and in turn, hopefully improve our understandings of the impacts of shifting conditions on these species that are fundamental to the ecosystem, as well as the Inupiat way of life.